Welcome to this video lecture on the topic binomial array and pattern multiplication. So in this, first of all, we are going to review the uniform distribution, where the uniform distribution of signal yield the maximum directivity and minor lobes are relatively large. So the amplitude of first minor lobe is 24% of the major lobe maximum. So the minor lobe amplitude may be undesirably large. So this kind of pattern has a half power bandwidth of 23 degree, but side lobes are relatively large. So for avoiding those limitations, we use a binomial array where arrays of non-uniform amplitudes are used as per the demand of the modern communication, where narrow beam is preferred. It is the greatest need to design an array of only main lobes. The ratio of power density of main lobe to power density of longest minor lobe is termed as the side lobe ratio. A particular technique used to reduce the side lobe level is called as tapering. The binomial array, since current amplitudes in the sources of linear array is non-uniform, it is found that minor lobes can be eliminated if the center element radiates more strongly than the other sources. Therefore, the tapering need to be done from the center to end radiators of same specifications. Binomial array is a common example of tapering scheme, and it is an array of n isotropic sources of non-equal amplitudes. To reduce the side lobe level, John Stone proposed the sources have amplitudes proportional to the coefficients of binomial series as given in this expression. So for the array of binomial, Pascal triangle is applied. So for the array of length, total length n lambda by 2, the relative current in the nth element from the one end is given by Pascal's triangle. For example, the relative amplitudes for the array of 1 to 10, the radiating sources are given by this triangle, where it starts from number of sources n equal to 1, and for n equal to 2 it is 1, and second source's amplitude is 1. So like this it is obtained by the binomial series. And uniform array versus binomial array. The radiation pattern is given. The uniform array secondary lobes appear, but principal lobe is sharp and narrow. Whereas in the Stone's binomial array, the width of the beam widens but without the secondary lobes. And disadvantages of binomial array: the half power beam width increases and hence the directivity decreases. So as the length of the array increases, the larger current amplitude ratios are required. So next is pattern multiplication. So this method is very useful in the design of array because it makes possible to draw the patterns of complicated arrays rapidly, almost by inspection. The total field pattern of an array of non-isotropic but similar point sources is the multiplication of individual source pattern and the pattern of an array of isotropic point sources, each located at the phase center of the individual source and having the same relative amplitude and phase. So the total phase pattern is the addition of the phase pattern of the individual sources and array of isotropic point sources. Here the linear array of 4 isotropic elements is given. The spacing between each element is same. So and the pattern multiplication is done for this 4 isotropic elements. And pattern multiplication for the 4 sources is given as the point P at which the resultant field has to be obtained. We can assume that radiation pattern from the antenna in form of parallel lines. So radiation pattern of the antennas 1 and 2 treated to be operating as a single, it is taken as 1 dash, and radiation pattern of the antenna 3 and 4 spaced distance apart and fed with equal current is treated as single unit again. So it is taken as 2 dash. So the length is lambda. Now both the antennas have bidirectional pattern, that is figure 8 pattern, spaced distance apart from each other, fed with equal current in phase. Now the resultant radiation pattern of 4 element array can be obtained as the multiplication pattern. So first in this diagram, unit pattern due to 2 individual elements is given and group pattern due to array of 2 isotropic is also given. So the pattern multiplication for the resultant pattern of 4 isotropic elements. And here is the linear array of 8 isotropic elements and equivalent 2 unit array spaced 2 lambda. It is given by pattern multiplication. So unit pattern due to 4 individual elements and group pattern due to 2 isotropic elements spaced 2 lambda apart. So the resultant pattern of 8 isotropic elements is obtained. And assessment questions. The pattern multiplication is the multiplication of single array radiation pattern with answer is array factor. The excitation amplitudes of binomial array follows the Pascal triangle. So thank you for listening this lecture.